So after discrete random variable, we want to learn continuous random variable. And why we learn continuous later? Because we no longer can just use summation, we need integration, because we are trying to adding something possibly infinite, right? So cumulative probability function, okay, is defined as the f of x is probability x less than x. It's no longer summation, but is integration from the smallest one, say negative infinity to the value x. Okay, so this is a little bit slightly different from what we have in the discrete, because usually we want to probability distribution function and then define the cumulative, but it's more natural to define this probability function, and this f is how we define f will be coming from probability density function. Okay, it's like this, is defined like in this way. So it's more like convoluted. So it's how do you define this? But right, because you need to define the small f in order to define the big f. But usually from the first principle, you define it based on a probability. Okay, from this probability, you can define the big F, and big F, you take a differentiation, you get the small f. So this is how things being done, but a little bit tricky. And the expectation and the variance also more tricky, because we cannot no longer use summation but integration, but the idea is the same. So we have to rely on more complicated tools.